Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video we are going to solve a question from the same JAM 2024 chemistry paper based on photoelectric effect. So before understanding the question, let us first try to understand what exactly is photoelectric effect. So this is also called as Einstein's photoelectric effect, as it was proposed by Albert Einstein. So what exactly we do here is there is one metal surface, okay, which metal we use? Metals from which the electrons can be easily removed, okay, where the electrons are loosely bound. For example, group 1, okay, group 1 and group 2 elements. Group 1, for example, sodium, potassium, lithium, all these metals, they can easily lose one electron, right? Sodium, we know it can lose one electron and form sodium plus electron. Or if we talk about group 2, beryllium, magnesium, calcium, strontium, okay, these electrons, for example, magnesium loses 2 electrons to form Mg2 plus 2 electrons, okay. So what we do, we take a metal surface. This box that you can see is a metal surface. What will happen? We incident photon, okay. What is photon? Photon is small energy packets, okay, small energy packets of light, okay, of light, or it is also called as quantum or quanta, okay. Singular is quantum. If there are more than one photon, they are called as quanta, okay. So photon or small energy packets we incident on a metal surface, and what will happen? Metal will lose electrons and these electrons are ejected, okay. After they are removed or ejected from the surface of the metal, they will move in one particular conducting medium and constitute current, okay. That current is called as the photoelectric current, okay. And the electrons that are ejected, they are called as photoelectrons. Why they are called photoelectrons? Photo means light, okay. These electrons are removed because we shine the metal with light, or we incident the metal surface with light. That is why this is called as photoelectrons, and the current that is generated, that is called as photoelectric current, okay. So now the question is, how can we prove that this photoelectric effect is taking place? So what you do is, you take this experimental setup, metal surface is given, you can see electrons are ejected, and you connect it with one particular circuit, okay, open circuit, which will be completed only when the electrons are ejected, okay. So you can see the electrons are emitted and they move through the wire and the bulb lights, okay. Bulb will light. When the bulb will light? When there will be current passing through the wire, okay. And if you want to measure how much current is passing, you can connect a ammeter. What is this called as? This is called as ammeter, okay. It is an instrument used to measure electric current, okay. Milliamps, ampere is the, okay, ampere is the unit to measure electric current, okay. So you connect the ammeter and measure the electric current. So in this way you can prove that the photoelectric effect is taking place. Now the question is, at any frequency of light will the electrons will be ejected? The answer is no. There is one minimum frequency, okay, minimum, or we can call it as threshold frequency. There is one certain minimum or threshold frequency. Only at this frequency, when you incident light, or when you incident photons on the metal surface, then only the electrons will be ejected, okay. If the frequency is less than threshold frequency, is denoted by nu 0 or nu naught, okay. If the frequency is less than threshold frequency, will there be photoelectrons? No, there will be no electrons, no photoelectrons ejected, no photoelectrons ejected. Only when the frequency is exactly equal to the threshold frequency, there will be photoelectrons that will be ejected, okay. Now suppose this is the frequency just to remove the electron from the metal surface, okay. This electron will be just removed from the metal surface. Now to constitute an electric current, okay, that is movement of electrons through a conducting medium, let's say copper wire, Will the frequency will play any role? The answer is no. Okay, after the electrons are removed, the constitution or formation of the electric current, okay, in the wire, okay, or we can say photoelectric current, that is dependent on, or the number of photoelectrons ejected after the threshold frequency is crossed, that will depend on the intensity. Okay, that will depend on the intensity of light. Now what is intensity of light? Intensity basically means number of photons. Okay, after the threshold frequency is reached, what will you do? You will increase the number of photons. Okay, you increase the number of photons, the number of electrons will increase. So is the current. Okay, current or the photoelectric current will also increase. Okay, so now let us see the question. Consider photoelectric effect. The number of incident photon is same for all frequencies. Plot that best describes the number of photons n versus frequency, incident light frequency nu. Okay, so this is a concept we saw just now. In order to release the electron from the metal surface, the incident photon has to first overcome the attractive force between the positive ion of the metal. So there is an electrostatic force between positively charged metal ion and the negatively charged electron. So you have to incident minimum energy, okay, with frequency nu naught, such that this force is lost or reduced, it, okay, diminishes this force, and then only the electrons will be removed. We have to overcome this electrostatic force of attraction. Electrons are removed, and then when you increase the number of photons, what will happen? The current I will increase, photoelectric current will increase. That depends on what we saw just now. It depends on the number of photons, okay, and not the frequency. Okay, number of photons or intensities increase, current will increase because number of electrons will increase. Okay, so the frequency which provides the enough energy just to release the electron from the metal surface will be the threshold frequency, that is the nu naught. For frequency, this is very important, for frequency less than nu naught, no electrons will be emitted. Okay, so now let us see the plots one by one. Initially at 0 frequency, will there be any number of electrons that will be present? The answer is no. So this should be 0, but here there is some value that is given, so this is incorrect. Here also there is some value that is given, so this is also incorrect. B and D, if you see at nu equal to 0, there are no photoelectrons that are emitted. Okay, but as you increase the frequency at one particular frequency, in both the graphs you can see the number of photons are increasing. This is nothing but the nu naught or the threshold frequency. Okay, now after the threshold frequency, what will the number of photons depend on? Will it increase linearly like this, or will it be something like this? So will it increase linearly? The answer is no. Okay, so what will happen at the threshold frequency, that is nu naught, what will happen? Let's say 100 electrons are emitted all at once. Okay, one single electron cannot be emitted from the metal surface. Okay, there will be several metal atoms present on the surface of the metal, so all those metal atoms will lose electron. Let's say 100 electrons are lost, so let's say this value is what? This value is 100. So all the 100 electrons are ejected. So you can see this point at nu naught, this is 100. After that, will it increase? No. After the threshold frequency is reached, I told you the number of photons, okay, number of photons does not depend on the frequency. It depends on what? It depends on the intensity, or we can say the number of photons. Okay, it depends on the intensity. Okay, as the intensity or number of photon increases, the number of electron will increase. Okay, n, small n, number of electron will increase and the current will increase. So what will be the correct answer? The correct answer will be option D. It will not increase linearly. Okay, it will remain constant. You will see any rise because at that particular moment when the threshold frequency is reached, these many photons, these many electrons are ejected. After that it becomes constant. It does not depend on the frequency. So the correct answer is option D. I hope you have understood this concept of photoelectric effect. Thank you.